Hello students, today in your calculus class we're going to be working on derivatives of trig functions. So let's get started. This would be a great time for you to try this warm-up, pause your screen. Hopefully you've paused your screen and you're just coming back to check your answers. So it says a ball is thrown straight up with s of t equals 5 plus 12t minus 16t squared, which represents the displacement of the ball, where s is measured in feet and t is measured in seconds. It says find the maximum height that the ball reaches. Now remember, if we solve this current displacement formula for 0, it tells us when the ball hits the ground on both sides. Now because they want us to find the maximum height, we're going to need to take the first derivative. So if we take s of t, we get 12 minus 32t. And if we set it equal to 0, this helps us find our maximum height. So we're going to subtract 12 to both sides, and we end up with negative 12 equals negative 32t. And finally, we get 3/8 seconds. Now, that tells us the number of seconds it takes to reach the maximum. But remember, the question is asking us for the maximum height. So now that we know how long it takes to reach that max height, we substitute that into the original problem. So we have s of 3/8 equals 5 plus 12 times 3/8 minus 16 times 3/8 squared. So when we substitute that in, we get 5 plus 9 halves minus 16 times 9 64ths. And we simplify that all the way, we end up getting 29 fourths, or 7 1/4 feet. So the maximum height of this ball is 29 fourths feet, or 7 1/4 feet. So again, we're working on derivatives of trig functions. Now, here's just a couple basics that you need to know to get started. The derivative of sine x is equal to cosine of x. And the derivative of cosine of x is equal to negative sine of x. So these are two very important things that you're going to want to write down. Everything else from here can be solved using the principles or using these two derivatives. So you definitely want to write this down and make a table, because we're going to give you a few more. So we're going to give you the ones for sine, cosine, tangent, cotangent, secant, and cosecant. So make room for those. But let's do a quick problem with these derivatives that you just learned. So in here it says find the derivative of y equals x cubed times sine of x. So remember that we need to use the product rule. And the product rule states that we do the derivative of the first. So derivative of the first times the second plus derivative of the second times the first. So that's exactly what we're going to do. Derivative of the first is 3x squared times cosine of x plus derivative of the second, derivative of sine x is cosine x, times the first. So that's x cubed. Rewriting this so it's cleaner, we are going to end up with 3x squared cosine of x plus x cubed cosine of x. And that's your derivative. So let's try another problem. Again, as we get to these u-tries, you want to try and make sure you pause it and solve it on your own. So here we have derivative of sine x divided by cosine of x. So what we're going to do is go ahead and do the quotient rule. So remember, that's low d high minus high d low over low squared. So that's low, we have low d high, so low d high minus high d low all over low squared. So what we end up having here is we have cosine squared x plus sine squared x. And if you're not sure how I got the plus sine squared x, you'll notice here that that is a negative or a minus, and we have another negative right here. So when you multiply that out, that becomes positive. And then we have cosine squared of x. And if you take a look at your trig identities that you learned last year, you'll remember that cosine squared x plus sine squared x is equal to 1. If you didn't, that'd probably be something you want to put in your notes. So essentially what we have here is cosine squared x plus sine squared x, that's equal to 1 divided by cosine squared x. And remember, 1 divided by cosine squared x is really just equal to secant squared x. So remember, we found that derivative just by doing the basics of our quotient rule and applying those new derivatives sine of x and cosine of x. So let's try another problem. No, before we do that, let's have you write down these in the notes that I asked you to make room for. So we know that derivative of tan x is equal to secant squared x. Derivative of cotangent x is equal to negative cosecant squared x. Derivative of secant x is secant x tan x. Derivative of cosecant x is equal to negative cosecant x cotangent x. So I wanted to, before we move on to the next slide, notice tan of x equals secant squared of x. That's the same thing we proved in the last one. But what you may not have remembered is that tangent of x is equal to sine of x divided by cosine of x. And so when we did the proof on the last slide, we were really proving that tan of x is equal to secant squared x. So again, please make sure you write these notes down. Here's one other thing that I'd like for us to add, which is a jerk. So I know you would say jerk and then think of me, but a jerk is the derivative of the acceleration. So remember, the first derivative from displacement gives us velocity. The second derivative from velocity gives us acceleration. The third derivative gives us jerk. So jerk is this idea of, a quick change in motion. So think of a knee-jerk reaction, that expression. Or think about when you accidentally slip and spill something. So these are all just knee-jerk reactions, or jerk is the official term. And again, that's a third derivative of displacement. The next one is simple harmonic motion. So simple harmonic motion, it is motion that repeats periodically. So you see this all the time. Simple harmonic motion we see in things like a swinging pendulum, the weight bobbing up and down at the end of a spring. If we look at this mathematically from your class last year, all of your sine and cosine graphs had that same up and down motion. Those are all simple harmonic motions. We also see these in sound. So maybe you don't see it in sound, but every time you hear sound, you're hearing these kinds of motions. So imagine a string instrument. If you pluck that string, it's going to vibrate. Now, if you were to track the motion of that over time, you would have simple harmonic motion. So, a weight at the end of a spring is pulled down 7 centimeters. So if you think back to your trig days, that 7 centimeters tells you your amplitude. Now it's pulled down 7 centimeters and then it's released. Its position at any time t is 7 cosine t. Notice the 7 because that's your displacement. It says calculate the velocity, acceleration, and jerk of the weight as a function of time. So to do this, we just need to take derivatives, which is pretty easy at this point, I believe. So the first derivative, remember, it's we can take the derivative of the function, and the constant can just be multiplied at the end. So the derivative of cosine t is negative sine of t. So really the velocity, put that in there, s prime is equal to velocity. That function is really just negative 7 sine t. The second derivative, which is your acceleration, is equal to, remember, now we're doing it based off of this negative 7 sine t. So the derivative of negative 7 sine t is negative 7 cosine of t. And the third derivative, which is jerk, is equal to negative 7 cosine, negative 7 sine of t. So those are your accelerations, or acceleration, velocity, and jerk. Hopefully this is not coming off as too difficult, but I'm sure you'll let me know in class if it is. Now, pay attention to the way they worded this. It says find the equation of a line normal to the graph of f of x equals 2x sine of x, 2x divided by sine x at x equals 2. Now remember, the first thing we want to do is find the y value at x equals 2. The second thing we want to do is find the derivative and slope. So we're going to do these in pieces. First, in order to find the value, we're going to plug the 2 in. So f of x f of 2 equals 2 times 2 divided by sine of 2 . So when we plug this into the calculator, which I'm going to do really quick right now. Let's see, going to metacalculator.com, we're going to do 4 divided by sine of 2. That's equal to 4.399. So f of 2 equals 4.399. Let's just say 4.4. So now we have an x and y value here. Now we're going to find the derivative of this. So remember, low d high minus high. Let's do that again. Low d high minus high d low divided by low squared. So this is going to become sine squared x. We simplify the top, we get 2 sine of x minus 2x cosine of x divided by sine squared of x. And now we found the first derivative. So this is the first derivative. This is still the first derivative. Now that we found the first derivative, we need to find the slope. So we need to find the slope at f prime of 2. So that's 2 sine of 2 minus 2 times 2 cosine of 2, all divided by sine squared of 2. So that's what we're going to plug into our calculator really quick. So I'm going to substitute in 2 sine of 2 minus 4 cosine of 2 divided by sine squared of 2. and we get 0. But because I did this on this calculator, let me try it one more time just to double check. We have 2 sine of 2 minus 4 cosine of 2 divided by, I'm going to type this in a different way this time, so we're going to say sine of 2 squared. That seems more appropriate. Then our answer here is going to be 4.2. So that means our slope here is equal to 4.2. Now that we have the slope, we need to find the equation for the normal. So remember, this gives us our tangent slope. So our tangent slope equals 4.2. Excuse me. The normal slope is equal to the negative reciprocal. So it's really just negative 1 divided by 4.2. So we still need to write an equation. So I know this is a long problem, but hang in there. So we're going to move the things that we have to the side. We know that the equation of a line can be found by using point slope form or slope intercept. We're going to go ahead and use point slope form. So that's y minus y sub 1 equals m times quantity x minus x sub 1. So we get y minus, the y value here was 4.4 because we calculated that from the original equation. The m is our normal line. So we need the negative 1 divided by 4.2 times x minus our y value, or our x value, which is 2. So this is y minus 4.4 equals negative 1 divided by 4.2x plus 2 divided by 4.2. We're going to add 4.4 to both sides. We get y equals negative 1 divided by 4.2x plus 2 divided by 4.2 plus 4.4. So if we punch that into our calculator really quick, we will get 4.876. So 4.876 is what we're looking at. 4.876 before I forget. So the tangent or equation of a normal line is y equals negative 1 divided by 4.2x plus 4.876. So hopefully that wasn't too bad. Remember, we found the y value at x equals 2. We found the derivative and the slope and plugged it into our point slope formula. This one's a little bit easier. Find the equation of a line tangent. So the tangent means we don't have to do the negative reciprocal, but we do need to find these values. So again, we're going to find the value at x. Find the value at x equals 3. So cosine of 3 divided by 3 is going to give us that y value. So we know here that y is equal to so we're doing cosine of 3 divided by 3. We get negative 3.3, negative 0.33. It's negative 0.33. Okay, now that we have that, we'll move that to the side. Now we need to find the derivative. So find derivative and slope. So we know we're trying to find derivative of the function. So again, that is low d high minus high d low all over low squared. Now we're trying to find the slope at 3, so that's going to now be 3 times negative sine of 3 minus cosine of 3 times 1, all divided by 3 squared. We're going to take that and plug it into our equation again. So we're doing 3 times negative sine of 3 minus cosine of 3 divided by 9 is equal to 0.0157. 0.0157, that's your slope. So now we have the y value, we have the slope of the tangent, and then we do point slope form again. So y minus y1 equals m times quantity x minus x sub 1. Substitute the y value in, which is negative 0.33 equals 0.0157 times x minus 3. Weight of the y plus 0.33 equals 0.0157 x minus 3 times 0.0157. So let's punch that in really quick. And that's 0.047. It's 0.047. Then we're going to add 0.33 to both sides. We get 0.0157x minus, actually, plus, let's do this really quickly. Actually, let's just do this in the calculator because I don't want to waste your time. So that's 0.33 minus 0.047. That's 0.28. And so that's your equation. So that's all for now. I know you may have some questions. This would be a great time for you to write that down. We'll do some practice problems in class. But otherwise, that's all for now. I'll see you guys next time.